Have you ever wondered about the different types of radioactive rays? These invisible forces are an intriguing part of the natural world, and understanding them can shed light on many scientific phenomena. Radioactive rays, also known as ionizing radiation, are streams of high-energy particles, or waves, that can alter the atoms they encounter. They're produced by unstable atomic nuclei and certain types of high-energy particles. Their importance? Well, they play critical roles in various fields, from medicine to energy production, and even in our understanding of the universe. But it's not a one-size-fits-all kind of deal. There are three main types of radioactive rays: alpha particles, beta particles, and gamma rays. Each has unique characteristics and interacts with matter in different ways. With this basic understanding, we're ready to delve into the world of radioactive rays. Let's dive deeper and start by discussing alpha particles, shall we? Alpha particles, the first type of radioactive rays we are discussing today, are fascinating. At the heart of every alpha particle, you'll find 2 protons and 2 neutrons. This molecular arrangement gives alpha particles their unique characteristics and sets them apart as the heaviest type of radioactive rays. Now, you might be wondering, why does their weight matter? Well, it's because their weighty composition contributes to their distinctive behavior in different environments. Now let's talk about penetration, or rather, the lack of it when it comes to alpha particles. Imagine a sheet of paper. Thin and light, right? Well, that's all it takes to stop an alpha particle in its tracks. Even the outer layer of human skin is enough to halt an alpha particle. Yes, you heard that right. The heaviest of all radioactive rays can't penetrate the thin layer of dead skin cells that cover our bodies. Isn't that something? Despite their lack of penetrating power, alpha particles are not to be underestimated. They hold a significant amount of ionizing power. This means they are incredibly effective at knocking electrons off atoms, creating ions in the process. It's a bit like a heavyweight boxer in the ring, powerful but not particularly fast or agile. But what does this high ionizing power mean for us? Well, while alpha particles can't penetrate our skin, if they are ingested or inhaled, they can cause serious damage inside our bodies. Their high ionizing power allows them to disrupt biological cells, potentially leading to illnesses such as cancer. To sum it up, alpha particles are a fascinating paradox. They are heavyweights in the world of radioactive rays, yet they can be stopped by a simple sheet of paper. They lack penetration, but possess high ionizing power, making them harmless outside the body, but potentially harmful inside it. Now that we've covered alpha particles, it's time to move on to beta particles. Beta particles, our second type of radioactive rays, are quite different from alpha particles. Let's delve into the fascinating world of beta particles. These are not like your regular particles. They are high-energy, high-speed electrons or positrons. Yes, you heard it right, electrons or positrons. These are subatomic particles that are ejected from the nucleus of a radioactive atom, not from the electron cloud as one might initially think. This happens during a process known as beta decay, and it's part of the magic that makes the universe tick. Now let's talk about their penetrating power. It's moderate, sitting somewhere between the lower penetrating power of alpha particles and the much higher penetrating power of gamma rays. This means that while beta particles can pass through a sheet of paper or your skin, they'll be stopped by a thin sheet of metal or plastic. This makes them potentially harmful if they come in contact with living tissue, but manageable with the right precautions. Moving on to their ionizing power, it's also moderate. Ionizing power refers to the ability of a particle to knock electrons off atoms as it passes by, creating ions. Beta particles are more ionizing than gamma rays, but less so than alpha particles. This ionizing power, combined with their moderate penetrating ability, means that beta particles can cause damage to living cells if they are ingested or inhaled. So, what's the takeaway here? Beta particles, these high-speed, high-energy electrons or positrons, play a significant role in the radioactive decay process. They have the power to penetrate and ionize, but that power is kept in check by simple barriers like thin metal or plastic. They're a key player in the grand scheme of radioactive rays, embodying the middle ground between the extremes of alpha particles and gamma rays. With beta particles covered, we can now transition to our final type of radioactive rays, gamma rays. Last but not least, we have gamma rays, the most powerful of the radioactive rays. These rays are quite the characters, possessing traits that set them apart from their alpha and beta counterparts. Now, what exactly are gamma rays? Well, they're a form of electromagnetic radiation, much like X-rays or the light we see every day. But don't be fooled by this comparison. Gamma rays are far more powerful than any light we can perceive with our eyes. One of the most notable characteristics of gamma rays is their high penetrating power. Imagine a ray so powerful it can pass through several centimeters of lead. Yes, you heard that right. Where alpha particles struggle to get through a sheet of paper and beta particles can be stopped by aluminium, gamma rays laugh in the face of such barriers. They can penetrate deeply into many types of material, making them both incredibly useful and potentially dangerous. Yet despite their impressive penetrating power, gamma rays have relatively low ionizing power. This means they're less likely to knock electrons off atoms and create ions. It's a bit like being able to walk through walls without disturbing a single brick. With that, we've covered all three types of radioactive rays. Let's summarize what we've learned. Today, we ventured into the fascinating world of radioactive rays. We've discovered that alpha particles are heavy and slow, with strong ionizing power but low penetrating ability. Beta particles, on the other hand, are lighter and faster, with moderate ionizing and penetrating capabilities. Lastly, gamma rays, being pure energy, have no mass, but possess the highest penetrating power and low ionizing ability. The world of radioactive rays is complex, but understanding them helps us appreciate the wonders of the universe. Stay curious and keep exploring.